Welcome to a Keras walkthrough. Keras is a high-level neural networks library. It is written in Python. It can work on top of both TensorFlow or Theano. Let's get started. Keras lets you model these artificial neural networks very easily. Keras is very simple to use and it is a prototyping tool. It reduces the time for concept to completion. Keras lets you build feed-forward neural networks, convolutional neural networks, and recurrent neural networks, and as well as the combination of all of these. It runs seamlessly on CPU and GPU. Before we get started with the coding, let's see how to install Keras. These are the dependencies for Keras. We'll be installing these, and you don't have to worry about them because on installation of the ones on the left, we'll automatically install NumPy and SciPy. So let's get started. So first we install Python. You all should already have it, but then just to make sure, you can just run this command. So I already have Python, and now let's install a Python package installer. It's installed. Now let's install a virtual environment, a virtual ENV it's called. It lets you have different virtual environments of Python for each of your project. So virtual environment installed. Now let's start a new virtual environment for our project. Let's call it VNV. So it's done. You can see that there's a virtual environment. Let's activate the virtual environment by the given code: source, the name of the environment, bin, and activate. So I'm working on a Debian based system. I'm using Linux Mint at 64-bit. If you're using other systems like CentOS, or if you're using Windows, the command might be a bit different. Check the documentation. So now that we are in the virtual environment, let's install TensorFlow. So I'm using a GPU system. I have NVIDIA GeForce 940M. If you have a CUDA supported GPU, please install the TensorFlow with GPU. That you can just write TensorFlow-GPU. If you don't, just go ahead and just write pip install TensorFlow and then click on enter. So I have a GPU, so I'm going to do this. It will take some time to install TensorFlow. Okay, so TensorFlow is installed. Now let's install Keras. Pip install Keras. If you're using a virtual environment and you're installing TensorFlow and Keras, outside the virtual environment you will not be able to use Keras or TensorFlow. So always activate the virtual environment before you start working. So I have installed Keras. Now the installation is done. Let's go back and get started with how to code on Keras. Thank you. When you're working with Keras, you have to follow a life cycle. That is a set of 5 steps that you have to always go through before you develop anything. So the first step in the life cycle is to define the network. So you have to tell the Keras how many layers you have in your neural network, what optimization to use, what are the activation algorithms that you have to use, like for example rectified linear units. After you define the network, you have to compile the network. When you compile the network, you get an object. It's a model object having all characteristics that you had defined. After you have this model object, you can give it the training data so that it can fit the network, that is, change around the weights so that it trains to predict what you're trying to classify. After you fit the network, you can test or evaluate the network using a test data. Test data is usually a segment of the whole data set that you have. The whole data set that you take, you segment into two. The bigger set would be the training data, and a smaller segment of it would be used for testing. And then third is you can move the model into production by when you give it new data, it would predict and classify into what class the input belongs. So let's work by an example. Let's see how Keras works using MNIST. MNIST is a data set of handwritten numbers. So each input in this is a 784 pixel representation of a handwritten number. So we will build a neural network model to predict which number does the input represent. So we will be building a simple feed-forward neural network which has 3 layers. So let's get started. So you can see on the right that this is how the representation of the handwritten number looks like, and then there are 784 pixels which are densely connected to the next layer. So let's go ahead and start coding. So when you're working with Keras, you have to import NumPy. NumPy is used to format the data for Keras. So let's go ahead and import NumPy as NP, and we can have, then we have to import the MNIST dataset, that is Keras.data sets import MNIST. Yeah. Now the model, the main type of model in Keras is a sequential model, and that is a linear stack of layers. For complex architectures, you should use the Keras functional API. So let's go ahead and import the sequential. So from Keras models import sequential. Let's import the dense, dropout, and activation. So dense is the type of connection for the neurons. Dropout is it's again a term from neural networks, and activation is how the neurons get activated based on its input. So let's from keras.layers.core import dense, dropout, and activation. Now let's also import the optimizer. So there are various types of optimizers, for example backpropagation. So we'll be using one form of that, that is let's import keras.optimizers import RMS prop. Yeah. Let's also import the utility functions, that is the utils from NumPy. That's already available in the keras.util, so we just keras np_utils. So we have imported everything that we need. Now let's go ahead and get the data from the MNIST database. So let's say xtrain y_train, that will be the training data set, and then let's segment it to test, xtest, and y_test. Yeah. So this let's get it from MNIST dot load_data. The load_data will return the data segmented into 2, and it also shuffles and splits the training data. So now that we have the data, let's go ahead and then reformat the data so that we can use it in Keras. So xtrain is equal to x_train dot, we have to reshape it By reshape, I mean the data is represented in terms of a matrix. So we have to flatten it so it is easier for us to input it into Keras. So we will reshape it into a 784 single dimensional array. So we have 60,000 samples of this for training, and each one is of 784 pixels each. So that's for X-train. We have to do the same thing for testing. So let's go ahead and do that. So that's done for testing. Now we have to change the type. So right now the representation is $float. So we're going to change that into float. So it's equal to x underscore train dot as type float 32. Should do the same for the testing as well. So there you go. Now the representation is actually in pixel format, that the data is from 0 to 255. So when we input that into Keras, we can normalize it for better results. So we will go ahead and divide the whole of X-train, that is each value is represented by 255, a number from 0 to 255. So when we divide it by 255, we'll get a number between 0 and 1. So X-train is divided by 255 would be X-train, and let's do the same thing for test. So now that we have reformatted the data, we can print out how many samples we have in X-train. So the shape returns the shape, that is the shape of the matrix. So the first dimension of the matrix would give you the number of training samples that we have. So that would be the training samples. And let's also print out the test samples. So that's it. So now that we have printed those two out, now let's go ahead and reformat the training part. NP utils as we imported to categorical of y underscore train, that's a small y underscore train, comma the number of classes. Let's say let's define a new variable called number of classes. So we haven't told MNIST how many classes are there. Let's go ahead and define a set of hyperparameters. So number of classes is equal to, we have 0 to 9, so number of classes will be 10. And so let's define the other hyperparameters later. So we have to do the same for test. So y test is equal to np utils to categorical of y test and this same number of classes. Now that we have the data in the format that we want, let's go ahead and define the model. It is to start defining the model. It's as simple as calling sequential. So creating an object of sequential. So now that you have model, we want to add characteristics to your model. Let's go ahead and add a layer to it. So what type of layer do you want? I want dense layer that is fully connected. How many net neurons? I need 512 neurons. And input shape, that is, so we have the input as 784 pixels from MNIST. So I'm going to define the input shape as that. Now that that is done, so Keras, it's so simple. You can just write model.add and then it adds it to the model. So I'm going to write the activation type of the layer is going to be ReLU. ReLU is actually rectified linear units. So if you know neural networks, if you learn machine learning, you would know what rectified linear units are. There are also linear units and other different kinds of units that are available. So model dot sorry about the noise. There's construction outside. Um, so let's add dropout for this layer. So we can say dropout. Let's say a probability of 0.2, and then model dot add. Let's add another layer. So we'll be dense again, 512 neurons. We'll add activation just like before, the same rectified linear units. Again we'll add dropout at the same probability. Let's add the output layer, that's the final layer. So model dot add. So now again you need dense, but you need only 10 because we only need 10 classes that we are predicting to. So model dot add. The activation layer for the last would be softmax. This is again something that you would know if you have learned machine learning. So now we have defined our model. We can print out the summary of the model using model.summary. So going according to the flow diagram that the life cycle that I told a few minutes back, we have already defined the model. Now we have to compile the model. So we'll go ahead and do that. Model.compile. So compile. See, the loss is categorical cross entropy. So cross entropy. We will have an optimizer that is RMS prop, and we have the metrics as accuracy. Correct. Now we have compiled the model. Now remember we have to fit the model. So history is equal to model dot fit, and we are fitting the model using the training data. So we go ahead and give it the training data. So make sure you give a capital Y there, that is the categorical form of the smaller y. And let's go ahead and say fit the model in batch sizes. So batch size is when training does not happen with the whole data set together. It divides it into small batches, and that's how training works. And a run through of the whole data set would be one epoch. So let's go and define in our hyperparameters what the batch size is. So batch size can be let's say the batch size is 128. Can be any number. Now that, and we also need the number of epochs that this training will run for. So let the number of epochs be 10. And so we have the batch size. We will say the number of epoch is equal to number of epoch, and we'll say verbose is equal to true or 1, and validation underscore data is equal to, and let's give it the validation set, or we can say that's the test set y, again capital Y. Now that is done, now let's evaluate the model by score is equal to model dot evaluate. And we pass it the test data x y underscore test, and let's say verbose can be 0 also. If you want it to be more verbose, just go ahead and go write 1, and let's see what the test score will be. Score comma score, and that will be there in the first. And let's print out the accuracy. optimize this code one. I'll go and save that. I think the program is right. Let's go and run this. So yes, there you go. So Python mnest. Oh, there's an error. Can't assign to function call. Okay, let's see what the problem is. Got load data. Mnest dot load. Oh, okay, that's a comma there. I forgot. So let's go ahead and run that. So start running. Oh, another error. Oh, spelling mistake. Keras. Hope it runs now. Ah, another error. Reshape 60,007. Oh, okay. Oh yeah, that's because there is no 60,000, so it's 10,000. You can run that. Oh, input shape is not defined. Input shape, again, I always make this mistake. Its input shape is equal to. Input shape is equal to. And there you go. It printed the model summary, but compile, something wrong compile that we gave. What's wrong with compile? RMS prop optimizes RMS prop, cross losses, cross entropy, metrics is an error is at least 3. That's weird. I have given 3 metrics receive. It's correct. So I'll just pause the video 1 second. So I figured out that I wrote optimizers, but it's actually optimizer. So let's go ahead and run it again, and hopefully it works this time. So yes, it started running, and it's running the first epoch. So you can see that it's using my GPU, and I have a GeForce 940M, and it has 4 GB of GPU they can use. So it's in the second epoch, and now you can see that the accuracy, the first time it ran it got 92% accuracy, and then 96, 97, and then we are running it for 10 epochs, and you can see that approximately it takes about 7 seconds for each epoch. So fifth, let's see. So the accuracy is continuously rising. So I think it'll probably, the model can reach only up to 98% accuracy. It's not going to go to 99. So it's the 8th epoch, and the accuracy is 99. Wow. And epoch 9. And epoch 10. I did not expect an accuracy of 99%. I thought it would be around 98. So yes, the test accuracy. So you can see that the test accuracy is only 98%, and it did not reflect the 99% from the training data. So that was a bit overfit, I can say. So that's mnest using Keras. Let's walk through another example of Keras. We will train a neural network to do sentimental analysis of movie reviews. We will use convolutional neural networks along with LSTM for this example. Let's go again and import NumPy as before. So import NumPy as MP. And before we start, let's import a few things from Keras. Keras dot pre-processing import sequence, and from Keras dot models. Let's import the sequential, and now let's import the dense dropout and activation from Keras dot layers. Import dense dropout and activation. And now let's import embedding layer. So embedding is what we'll use to convert the it's something more like the word to vec for converting words into vectors. So we'll represent a finite vocabulary. So let's do the layers, import embedding, and let's import Keras. Let's import LSTM. So layers, import LSTM from Keras layers, import. Let's import convolution. Convolution 1D is what we'll use. We'll also use max pooling 1D. So max pooling is what will bring down the convolutional filter. We'll talk about that when we write the code for it. So from Keras, let's import the IMDb dataset. So IMDb. So Keras will download the dataset for you. You don't have to worry about actually downloading it. If it's downloaded, it'll cache it, and then you don't have to keep downloading it. So this dataset is about 62 MB. So let's define a few hyperparameters. So parameters would be, let's say for embedding, the max number of features is 20,000. So for embedding the max features is 20,000, and the max len is let's say 100. Max len would be the number of words that can be in a review. So embedding size is equal to 128. That can be a number of your choice. Convolution, let's have the length of the filter. That's a hyperparameter. Let's say it's 5, and the number of filters, that will be 64, and let's say pool length is about 4. Okay, and for the LSTM, we can have LSTM output size is about 70. We'll have training, and for training, the batch size, like we defined before, let's have 30 this time, because the data set is pretty small. It's only 25,000 reviews. Actually not number size. Number of epochs would be, let's just run it for 1 for now, and let's say we are loading the data. So let's load the data, x underscore, the same thing that we did last time for mnist. That's small y train, comma, x underscore test. So that is imdb dot load. So now we are loading the data into these two tuples. So that will be nb words is equal to, that's the max features. Max features is the same as max words, and we can print out the length of x underscore train to see the number of training sequences, and we can do the same for test. Okay. Now Now see, different reviews come in different sizes, so what we have to do is we have to pad them so that they all come the same size. So let's add padding to the sequence, so that is x underscore train is equal to sequences dot pad underscore sequences of what are we adding padding to. It's the x train, and the max length is equal to the max length. So we assume that the maximum length of the sentence can be 100, that is, there can be 100 words in the sentence, and we have to do the same for test, sorry. So test, we have that. Now let's just print out the shape of both the training and the test. Shape is x underscore train dot shape, and again the same for the test. So test. Now now we can start defining the model. So let's say do model, just so that we know where we are in the program. So like before, model is equal to be an object of the sequential, and let's go ahead and add the first layer, that's the embedding layer. And we have to add the embedding input size, that's the max features, and we have the embedding size, and then we have the input length is equal to max length. Correct. So model dot add, let's add a dropout for this layer, drop out there of like 2.5. model dot add, let's add the next layer. Let's make it a convolutional 1D layer. So here are a few parameters that you have to enter. That is, let's say the number of filter is equal to the number of filter, and let's say the filter length. These are the hyperparameters that we had defined just above. So this is again the filter length, and let's say the border mode is equal to valid, yes, and activation, again this is like we discussed in the MNIST example. RELU is rectified linear unit, and see the subsample length is equal to 1. So that's the convolutional layer right there. And now, so for convolutional layers you have to have a method of pooling it. So we use the max pool 1D pool, and the pool length of that would be what we define. Pool length, that's that layer. Now let's add the LSTM layer. So model.add LSTM. So you can see that it's very easy to add layers in Keras, and you just have to pass the size and what's expected, and Keras does the job. So now that we have LSTM up, if you don't know what LSTM is the short form for long short-term memory networks, is usually called LSTMs, and it's a special kind of RNN, or recurrent neural networks. It's capable of learning long-term dependencies. So let's add the final layer. Let's have it a dense one, The size of this layer is 1 because we just have to indicate if it's a positive or a negative. So one one neuron's far more than enough for that. So, and activation for that would be let's change the we used softmax last time, and for this we can use a sigma, correct. So we define the network. Now it's time to compile the network according to the life cycle. So we will go ahead and compile. Let's say the loss is, this is the same as the last time, binary cross entropy optimizer. Let's use the atom optimizer, and the metrics is the same as accuracy. Yeah, so optimizer, we made the mistake last time. Yeah. Okay, now that we have compiled the model, now let's go ahead and train the model. Oh, sorry, model.fit, that's training. Let's pass the data, that's x train, and we have to pass y train. Batch size is equal to batch size. So the batch size here is 30, I guess, and the number of epochs we'll train it for is epoch, and validation data would be equal to, let's give the test double, test and y underscore test. So now we have fit the model. Now let's run the score and let's evaluate the model. So that's score and accuracy, that's small dot evaluate, passing the test data, that's x test underscore y underscore test. Again, batch size is equal to so let's print the score. Score and the accuracy. That's it. I think the program is done. Let's go ahead and execute it. It's called imdb. Oh, what is that? Oh, okay, this is models. So it's loading the data. That's good. So I had already downloaded the data set, so it should be using the cached one. Sequence is not defined. But it's sequence.bad. It's okay. Okay, we can wait. So I'll just change that. Okay. Should run now. Again, this is a spelling mistake at embedding. So it's building the model. Now it's training. So it's a pretty bad accuracy at 48% and now 50. I don't know, I think we might get about like 86% accuracy. I'm not sure, I've never done this before. I might fast forward this in the video so that the whole video is not too long. So we have an accuracy of 81%. Okay. Okay, so nice. We got a score of 33% and accuracy of 84%. That's pretty good for sentiment analysis. So that's it with the examples of Keras. So you can see that Keras is it's a very highly extensible neural network library. It's very easy to use and it is designed for programming very quickly. It is for prototyping. It is for you to convert your ideas into reality in the shortest amount of time. Thank you for watching.